Chapter number 3, representation of data, um, and 3.1, outliers. Outliers is usually unusually high or low values occur in a set of data, or we can tell extremes values. For example, assume that you have a set of data like this 4, 5, 8, 7, 6, and suddenly you will see that 165. Then it is very clear that 4, 5, 8, so this is all small numbers. Suddenly this is 165. It can be a recording error. When the numbers were recorded, the person who is making records did a mistake. So it could be, sometime it could be natural, but it's depend on the data set. Sometimes you may see something like this. 120, 135, 130, 128, and suddenly you may see that around 2. So when you look at this data set, so all around 100, and suddenly it's 2. It's too small. So this is also extreme value. This is all a unusual value. Both are extremes or unusual values. We already discussed what will happen for a mean if there is unusual value. It will give a different forecasting. In the sense, it will give inaccurate data. Now, when you look at this data set, you can identify what is the um, unusual value. So 20, 30, 40, 640. So it is clear that this is more than 100 and more than 500. This is an unusual value. So it is better to, so rather than finding the meaning of this one, divide by 4, it is a more accurate. 20 plus 30 plus 40 divide by 4, because this is very unusual value. Now we need to know kind of a rules to get rid of these extremes values. We can't just drop. So we should have kind of a theory to apply to get rid of extreme values. We have two ways of calculating mean and standard the outliers. One is mean and the standard deviation. Two different ways of calculating outliers. One is mean and the standard deviation, or quartile and interquartile range. With the mean and the standard deviation, we will take this is x bar, and standard deviation is let's say sigma equal s. Then it's going to be in this point x bar plus x s, and x bar minus s. Any values beyond this point, uh, called outliers. Sometimes you can use x bar plus 2s, but it has to be at least 2 standard deviations. So let's say this is 2s and plus 2s. So 2 standard deviation away uh, from the mean. So that is one method. The other one is if we know the data set, we know Q1 and Q3, and we know this different, let's say X. So then at least 1.5 at least 1.5 interquartile range beyond the nearest quartile. 1.5 interquartile range. This is the one x is the interquartile range. So 1.5 mean x 2 over 3 over 2 times x 1 over 1.5 x times beyond the nearest quartile. So if you say this is Q3, then we are finding the distance 1.5x and we will take this boundary. And from here we will take reduce 1.5x this gap. So that those two numbers, so beyond this point and beyond this point are going to be outliers. Usually we write this on upper bound is Q3 plus 1 point times Q3 minus Q1. It means for Q3 add 1.5 times of this gap, and for here Q3 minus 1 point times Q3 minus Q1. It means take away from Q1 uh, from this 1.5 times of this gap. But still this distance 1 point time or 2 you can adjust. But standard you can write Q through Q3 plus K times Q3 minus Q1, and this one you can write Q3 minus K times Q3 minus Q1. Assume we have this is 30, this is Q1 and Q3 40. So what is the IQR? IQR is 10 now. Q3 minus Q1, that is 10. Then outlier is the value, let's say it also a value. X1 is, let's say, X upper. Outlier X upper is Q3 plus 1.5 times Q3 minus Q1. So Q3 is 40 and 1.5 times this distance. So 1.5 times this distance. 1 point times 10 is 15. So then this is 40. We want to add 1.5 times 10, which is 40 plus 15. That is 55. So the upper boundary is 55. So this is the outlier area. Any numbers in that area is going to be outlier. Now in this side, it's lower Q3 minus 1.5 Q3 minus Q1. It means 30 minus, this is 15 again. So 30 minus 15 is going to be 15. So of any value below 15 is going to be outlier. So any value below 15 and any value above 55 is going to be outliers. Sometimes outliers values, sometimes it can be true values, or sometimes it is erroneous values. We call anomalies. So erroneous value due to maybe a recording error or some other reasons. If there is erroneous value, so we have to remove the data, or we have to clean the data. The process of removing anomalies from the data set is known as cleaning the data set. But we cannot be removed just because they do not fit the pattern of the data. So when we clean in, we can't do a cleaning just because it's not just fit to the pattern of the data. It has to be a erroneous value. We'll discuss example now. This is example one in the book. I just marked the uh, numbers like this, all the data in the number line. And first of all, this is 30. The blood glucose of 30 females recorded. The result is uh, so we want to find the outliers. So 1.5 times interquartile range. So first of all, we want to find upper quartile and lower quartile. So upper quartile is, we know this is 30 data. 30 divided by 4, that is 7.5. It means round up. So this is 8 term. So 1, 2, 3, 4, 5, 6, 7, 8. So 3.2 term. 1, 2, 3, 4, 5, 6, 7, 8. So this is the term Q1. And 30 divided by 4, 3. That is going to be 22.5. Round up. That is 23rd term. So 23rd term. So this is 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. This is the 23rd, Q3. Now, IQR. This is IQR. This length. What is this length? IQR is, so 8 terms is 3.2 and this term is 4. So 4 minus 3.2, which is 0.8. So 0.8, this distance from 3.2 plus 4, 0.3.2 plus zero point 0.8, 4. So this is the IQR range. Now I want to find the outliers. It means 1.5 of IQR. So first of all, find the outliers. I want to calculate this value. So 1 point times 0.8. So this is going to be 1.2. Then from this outlier, I want to add 1.2. So what is Q3? Q3 is 4. Then I want to add 3 times IQR, which is 4, 3 times 0.8, 4 plus 1.2, 5.2. So we have the 5.2. Actually, I changed this last one to 5.3. So 5.2 somewhere in the middle. There is no particular number for it. This is the upper limit of the outlier, 5.2. And we can find the lower limit. So we want to upper limit. Then we will find the lower limit. So that is going to be lower boundary. The first Q1 minus 3 times, 1.5 times this one. This is 1.2. Not 3 times, 1.5 times. Um, that's what the sum need. 1.5 times interquartile range, that is 0.8. So Q1 value is 3.2 minus 1.2. It means the value is going to be 2. So the lower limit is going to be here. This value 5.2 and this value, this is going to be 2. There is no value. So the other values beyond those 2 points is going to be outlier. So I can see one outlier here, 1.7, and the other outlier here is 5.3. So there are two outliers. There are two outliers. I modified this example number 1 by putting 5.3 instead of 5.1. So one is 1.7. They are 1.7 and 5.3. This is 1.5. 1.5 times after this is also I can write Q1 equal 1 point times IQ. This is we are using a skills for grade 7 and grade 8. There is no any A level matters, just to this idea, and after that this is multiplying and minusing, addition minus, they all are year 7 year 8 skills knowledge levels. Simply select in the number line, you select 2 point and beyond this 2 point outliers. So how do you select this point? 2 points, you bring Q1 and Q3. So this is the starting point, Q1 and Q3. You can find Q1 and Q3 first quartile. Then find that range and take 1.5 time according to this sum, and at 1 point time to here minus 1 point time to here. That's all, very simple. And for this data test set, I calculated x bar. So other way of finding outlier is x bar. X bar going to be 3.69. So 3.69, not 3.7. So somewhere here x bar, and and so x bar is 3.69. I want to find upper value, upper extreme value. So I want x bar to add the 2 times of sigma. So x bar plus 2 times of 0.84. So x bar is 3.69 plus. So this is going to be, so according to this one, the value is going to be 5.37. 2 times sigma 0.84. It means this is the uh, upper boundary for the extreme value. The boundary for extreme values. So this value is 5.37. So then according to this value, there is none remain outlier in this side. Now we'll look at the lower limit. Lower boundary for extreme values. X bar 2 times sigma minus 3.69 minus 2 times 0.84. 3.69 minus 1.68. So this value is going to be 2.01. It means 2.01 is going to be somewhere here. 2.01. So according to this one, this is only one extreme value. There are only one extreme value, that is 1.7. With the interquartile range we get 5.3 as well, but we will just miss this one, 5.37. Now we'll discuss exercise 3a.